On October 7, 2025, the European Space Agency unveiled the initial official photo of 3I/Atlas, an interstellar visitor spotted gliding close to Mars. Everyone anticipated a major discovery. What came instead was a dim, blurry spot and 4 days of total quiet from all the prominent space organizations. Why would NASA, along with China and the UAE, withhold their top-quality shots while only ESA attempted to dismiss chemical signatures that defy explanation? A path that's nearly flawlessly precise and a surrounding glow almost entirely made of carbon dioxide. If 3I/Atlas turned out to be merely another comet, why does each response only spark further doubts? And what secrets do those 7 probes hold from the public? Here's the tale behind the photos that reshaped our understanding. Back on October 2nd, 2025, shortly past 9 a.m. Mars local time, the Perseverance rover's Skycam grabbed a shot that no one thought would count for much. Skycam serves as a broad-field color camera, crafted to track dust storms, cloud formations, and the edges of the Martian landscape, not to hunt down objects from beyond our solar system. Yet, as anticipation built for detailed orbital views, this unassuming device delivered the earliest distinct glimpse of 3I/Atlas approaching Mars. The raw image NASA shared afterward revealed a subtle green-ringed mark on the pale expanse of the Martian atmosphere, so faint that it might have gone unnoticed without the added label. The challenges for spotting it were immense. Mars's daytime glare spread sunlight via airborne particles, rendering distant stellar travelers practically unseen. With its setup geared towards scenic vistas, the Skycam sensor had trouble extracting details past the most vivid elements. Still, Mallory Leafland, who led the rover team that shift, insisted on keeping the feed active. She contended that even a shaky grab could mark a pivotal moment, particularly amid the U.S. government shutdown that risked halting non-critical tasks. Her decision turned out golden. That frame, logged at 0918 Mars local time, marked the inaugural solid proof of 3I/Atlas entering the vicinity around Mars. No other gear on the red planet could scan the full heavens simultaneously, let alone under bright conditions. As orbital craft and research lenses held out for ideal positioning, Skycam's expansive scope allowed it to snag the surprise arrival. The outcome wasn't glamorous, just a rough smudge hardly separable from static, but it existed beyond dispute. This lone capture from a tool designed for atmospheric checks laid the groundwork for all subsequent sightings. The quest for clarity suddenly had its origin. An authentic surface-level view from an alien world, depicting an interstellar body overhead in Mars's airspace. By October 3rd, 2025, a remarkable lineup formed over Mars. 7 distinct spacecraft, each equipped for unique roles, aligned to monitor 3I/Atlas as it zipped within roughly 30 million kilometers of the surface. This wasn't your standard pass-by. It represented a rare team-up of detection tools, all set for one shot at an outsider from deep space. HiRISE, the sharp imaging system on the Mars Reconnaissance Orbiter, excels at rendering Martian terrain with exquisite clarity, detailed enough to reveal rover tire marks. But its limited scope made nabbing a speeding comet at such range like hitting a pinpoint in the stars. COMOS on the ExoMars Trace Gas Orbiter provided greater adaptability. Its black-and-white setup could layer multiple shots, sacrificing some crispness to detect dim, wandering objects. Themis aboard Odyssey, focused on infrared bands, aimed to pick up heat traces, though success seemed slim. Typical comets evade its gaze unless they're actively releasing vapors or particles. Mars Express chipped in with a pair of analyzers, Omega and Spicum, both geared toward charting ground minerals and air components. They shone in breaking down the coma's makeup, hunting for signs of carbon dioxide, ice, or unusual elements. Nomad, another analyzer on the Trace Gas Orbiter, specialized in sifting out the subtlest hints of unstable substances, which might hint at the visitor's cosmic roots. China's Tianwen-1 mission brought varied spectral and radar capabilities, stand out for probing makeup and form if the angles aligned. The UAE's Hope Orbiter, orbiting farther out, supplied UV and visible light oversight attuned to shifts in the coma's glow and outline. Every device grappled with obstacles. intensity far dimmer than usual subjects, following a shifting speck through the heavens, and tight windows for data collection. For a brief stretch, though, Mars turned into the solar system's prime observation post. The complete lineup, from pinpoint visuals to chemical scanners, prepared to gather irreplaceable intel. In that narrow opportunity, the potential shone bright. If any oddity or insight awaited, this was when the global fleet of satellites and landers would seize it. ESA's announcement hit on October 7th. Rather than a crisp depiction, viewers received a cycling video, a vague, indistinct point meandering over a dark backdrop, edged by a scarcely noticeable mist. This came from the Cosmos camera in action. Work on the ExoMars Trace Gas Orbiter focused on the anticipated trajectory of Comet 3/Atlas as it flew by Mars. The difficulty was enormous. Nick Thomas, lead investigator for CASIS, explained that the comet appeared at least 10,000 times fainter than the usual Martian objects his group monitors. To prevent signal distortion, Thomas restricted each frame's exposure to just 5 seconds. This cautious approach favored reliable data over eye-catching images. The final GIF condenses hours of work into mere seconds of movement, with every frame barely registering the object. Rather than revealing the comet's core, which stays indistinct even from afar, the sequence highlights its coma, a faint shroud of gas and dust spanning thousands of kilometers. The coma's glow diminishes quickly, blending into the ambient interference without showing any tail. ESA's release noted uncertainty in the spectroscopic evaluation, essential for determining makeup. The unprocessed data and initial products remain secured by the organization's routine 6-month hold. Just this refined teaser is available, standing in for more thorough examination still in progress. Public engagement requires some display, yet much of what CASIS recorded stays out of sight. ESA's media team advocated for a bolder visual, but Thomas held the line. No enhancements, no exaggerated adjustments. Misreading the results posed too great a danger, particularly amid whispers of odd compositions and potential oddities. At present, this restrained video offers the sole authorized peek, a humble yet essential document of a cosmic guest near Mars. Researchers worldwide await further insights, aware that the true revelations lie in datasets delayed for months. On October 4th, 2025, key figures from NASA, ESA, China's CNSA, and the UAE convened a private video meeting. Unlisted on any open schedule and without a leaked record, the discussion triggered swift repercussions. Over the subsequent 3 days, all Mars-watching organizations fell quiet. ESA alone shared output, one reserved video clip and a vague press note avoiding details. NASA blamed the U.S. federal shutdown for sparse news, though that didn't hold for European or Asian counterparts. Neither China nor the UAE, navigating their own governmental dynamics, provided any rationale. Within ESA, the strain was evident. PR specialists sought a thrilling unveiling to fulfill hype around a landmark cosmic rendezvous. However, safety experts and research heads resisted, drawing on terms typically used for asteroid threats, quirky early findings, risks of confusion, and calls for cross-agency scrutiny. Internal documents repeatedly warned that media hype could erode confidence more than build it. In the aftermath, preliminary announcements underwent repeated revisions, swapping references to peculiar reactions or baffling light patterns for neutral updates on continued review. The hush extended beyond omissions in displays. ESA applied its standard 6-month lock to raw CASIS files, while even basic metrics on light scattering and spectral traits got pared down severely. NASA's Mars Reconnaissance Orbiter and Perseverance crews issued only the labeled Skycam image, funneling questions to Central Command. China's Tianwen-1 and the UAE's HOPE mission, both primed for distinct wavelength and radar captures, stayed mum. No posts, not even acknowledgments of observation attempts. The normal flow of research, unrefined datasets, preliminary scans, operational notes, halted abruptly. Observers of space governance spot the anomaly. Rival entities seldom sink their reticence, particularly amid a spotlight event with breakthrough potential. The prior instance resembled this only during close asteroid passes tied to defense concerns, where premature info might spark alarm or mix-ups. Yet this involved a comet, posing no hazard. Thus, what irregularity could compel for distinct bodies, marked by competing agendas and tensions, to release merely the most guarded teaser? Speculation ranged from mistaking subtle readings or igniting tales of engineered sources to underlying clashes on validating and explaining initial signs of atypical elements or irregular light shifts. This unified restraint stranded experts in uncertainty. Engagement squads handled inquiries without responses. Hobby stargazers attempted but couldn't replicate the Skycam spotting, stoking talk that the core narrative lurked in restricted archives. For the moment, the sole assured element is that preliminary results contain something, be it a setup glitch, a genuine peculiarity, or merely the apprehension of unleashing a media frenzy had persuaded leading global space organizations to hold back. The push for transparent research had clashed against a barrier of prudence, with the information lingering behind it, awaiting judgment. The odds were stacked against 3I/Atlas from the start. Its route, deviating merely 5 degrees from the ecliptic plane while navigating past Mars in October and Jupiter's path in March, challenged all expectations. Experts at ESA's Space Situational Awareness Office crunched the figures. The likelihood of an arbitrary interstellar visitor tracing this precise alignment sits below 1 in 10,000. That orbit by itself sparked intrigue, particularly since the Flyby's celestial region grazed perilously near the position of the 1977 WOW signal. Formal reports brushed aside the similarity as mere chance, yet the improbability ignited discussions among the project researchers. Analysts examining light wavelengths encountered an odder enigma. Initial observations compared from VLT and JWST revealed prominent nickel atomic signatures without any iron presence. Typically in comets, nickel and iron emerge side by side, freed from particles by solar warmth or UV radiation. In this case, iron vanished entirely, even as nickel output surged dramatically nearing the sun. On August 21st, VLT detected a nickel release rate approaching 10 to the power of 22. 7 atoms/s, following a scaling pattern so sharp, declining with heliocentric distance to the theta power, that it surpassed any documented comet activity. Lab simulations suggest a single mechanism, nickel carbonyl, a fragile molecule that arises in CO-rich settings and decomposes under gentle warmth or solar rays, yielding isolated nickel atoms. Here on Earth, it's a manufacturing technique. Out in the cosmos, it's virtually unprecedented. The missing iron carbonyl traces and absence of any Phi emissions prompted specialists at DLR and INAF to hunt for plausible organic causes matching the data. The surrounding haze, probed by JWST in the near-infrared, unveiled another layer. Carbon dioxide comprised 95% of the identified vapors, an outlier proportion seldom observed. Water, the hallmark of typical comets, appeared in negligible amounts. Certain experts posited that extended interstellar travel might evaporate water ice, concentrating denser gases. Others speculated the imbalance could imply intentional design, like exhaust or fuel systems, although nothing concrete backed such a conclusion. At present, the CO2 heavy envelope served as a distinctive chemical marker, unusual yet feasible in natural contexts. Visual assessments introduced one more surprise. Instruments at Keck and VLT's first 2 captured unusually deep negative polarization, reaching -4% or greater in red light, well outside the norm for comet particles. Such negative values indicate the haze's grains diffuse light with a pronounced preference for backward scattering, commonly associated with tiny carbon-laden bits or metal aggregates. Among inner solar system comets, figures seldom fall under -2%. These results nearly doubled that threshold, holding steady over various tools and viewing angles. Instrument glitches couldn't account for it. The measurements aligned with reference stars and multiple checks. Collectively, the findings sketched an image far from typical. A hyperbola with eerie alignments to planets, a composition ruled by nickel and carbon dioxide, and light-scattering traits that strained existing theories. Individually, each oddity might pass as a rare quirk or chance event. Yet as observations accumulated, Upholding a unified everyday rationale became increasingly untenable. The restricted archives, unprocessed spectra, polarization data, and technical records emerged as the core of a scholarly conundrum requiring innovative insights. For the moment, all theories must grapple with these deviations: the course, the makeup, and the illumination. Researchers confronted an enigma calling for a new paradigm. For rival frameworks vied for validity, each charting a distinct route to resolution. The initial, most restrained view regards 3I/Atlas as a genuine comet boasting unusual reactions. Should this hold, upcoming observations ought to confirm ongoing nickel prevalence and CO2 abundance, while uncovering concealed iron or water features as the envelope develops. The next theory envisions it as a relic device, maybe a scout or monitor, lying inactive for eons. This aligns with the factory-esque nickel processes, but lacks signs of form or engineered transmissions so far. Just advanced radar imaging or odd rotation might sway the argument. The third envisions a functioning surveillance unit, fine-tuning its route for close planetary passes. The trajectory matches, yet no communications, expulsion adjustments, or power signatures appear. Spotting abrupt velocity shifts or luminosity changes post-perihelion would serve as the decisive proof. The final, boldest notion describes a composite vessel concealing a crafted interior within an organic casing. This could justify the commonplace surface alongside the bizarre reactions. Still, no clear non-natural actions have appeared. Only trajectory alterations after perihelion or debris showing unusual traits natural motion alone might verify the hypothesis. Every hypothesis depends on forthcoming evidence. At present, the observations are straightforward, though the conclusions remain elusive. On October 29, 2025, as 3I/Atlas reaches its nearest point to the Sun, observers across the inner solar system face a total blackout. From positions on Earth and Mars, the body vanishes behind the Sun's disk, obscured by an intense barrier of plasma and brilliance that renders optical and radio tools useless. During this 2-week interval near perihelion, the surrounding area becomes entirely invisible, omitting the vital period from all scopes and instruments. This obscurity extends beyond mere operational hurdles. It serves as an inherent veil right when comets typically exhibit peak dynamism, such as flaring up, breaking apart, or, should the entity prove unnatural, performing some adjustment. Planners for the missions simply must endure the pause, aware that abrupt shifts in path or emerging pieces will escape detection. Upon reappearance, the protocol is straightforward: monitor the route, detect any anomalies, assess the brightness of the coma, and probe for unforeseen escorts. Events hidden in the solar glare could determine the fate of competing explanations. Yet currently, the flow of information halts, forcing all resolutions to defer until the comet re-enters visibility in the evening heavens. In late November, the initial chance arises to spot 3I/Atlas once more following its concealment by the Sun. ESA's JUICE probe, now heading away from Jupiter, will direct its advanced Janus camera and Magus spectroimager along the anticipated trajectory. The alignment is precise, less than a degree from Jupiter's position, yet the spacecraft is ideally placed to image the coma assuming sufficient luminosity. JUICE's observations won't transmit immediately. Preliminary visuals may delay by 3 days, while comprehensive datasets could require up to 2 weeks for processing, calibration, and validation prior to archiving in planetary science repositories. Juno, maintaining its prolonged polar trajectory, will attempt its viewing in mid-March 2026. By March 16th, the probe's orientation enables JunoCam to inspect for venting streams or debris that could indicate non-gravitational influences. The time frame is brief, and the transmission process is gradual, with photos potentially needing a month or longer for public dissemination. Both missions' crews are developing backup strategies should 3I/Atlas alter its course unexpectedly or fade in intensity. Meanwhile, global audiences hold their breath as these far-off observers calibrate their equipment, eager to witness the unfolding drama that has already transformed protocols for studying celestial intruders. Even with 7 probes queued for sightings and Perseverance's prior sky survey, NASA, China, and the UAE have withheld their visuals and analyses. This unified reticence, noted in an agency-wide discussion on October 4th, deviates from norms in collaborative astronomical efforts. Disclosed information points to an orbit with under 0.1% likelihood of being purely natural, a spectrum dominated solely by nickel, and a surrounding envelope of 95% carbon dioxide. Distinct from every cataloged comet, specialists concur that 3I/Atlas's essence stays undetermined, with essential evaluations postponed beyond the October 29th solar occultation. As ESA and partners gear up for upcoming disclosures and JUICE's November assessments, a key truth persists. This major interstellar passage since Oumuamua has sparked far more inquiries than resolutions. Future snapshots could fundamentally alter our grasp of extraterrestrial sojourners in the solar system.